Okay, let's check out the Caspian Sea, which is this body of water here. It's right next to the Black Sea, which is right next to the Mediterranean. All three of these are saline bodies of water. Okay, let's zoom in to the north coast of the Caspian Sea. And the first feature that really pops out is this massive alluvial fan. This is a huge feature of deposition. All of this sand was deposited completely underwater, and we can see that it connects with a very large river valley. So let's first get an idea of the width of this alluvial deposit. It's over 140 miles wide, so that's quite impressive. We zoom into the river, or the channel width up here. It's kind of a messy river channel, but it's an 18-mile wide channel, so that's impressive. We go over here, we find parallel path features. This is something that's highly correlated with sheet water flow. Okay, now what really makes this spot incredible is this textured surface. These are parallel mounds of sediment, parallel lines of sediment. Now this is a fluvial feature called the drumlin. Now if you know what a drumlin is, you're probably saying a drumlin's not a fluvial feature, it's made from solid ice, it's made from a moving ice sheet. Well, there's many reasons why that can't be the case. Maybe the first reason I'll state is that it's highly correlated with salt. Everywhere you find drumlins, you can also find salt. I'd say probably about 60 to 70% of drumlins on Earth have a salt correlation, maybe even higher. And this is one of those locations, and we already know that it's next to saline bodies of water. But the other feature, the other reason why we know it can't be from an ice sheet is because an ice is a solid object, which means it responds to rigid body dynamics and not fluid dynamics. So it's a completely different field of physics. And only laminar flow can explain drumlin formation. That's the only principle of physics that can explain drumlin formation. So because there's no laminar flow with an ice sheet, it has no real physical explanation. That's why many scientists are now starting to adopt the idea of the subglacial flow model. This does have its flaws because it doesn't explain where all this water came from and how it was catastrophically released and why this water was saline. But nonetheless, it's a step in the right direction in understanding drumlin formation. Now, this drumlin pattern is actually connected with an expansion bar. Now, it's very hard to see here, but we've got an 18-mile wide river channel here. And if you look very closely, this is actually a river channel here. Okay, I'm going to change the exposure and the contrast so that you guys can see this. But it's basically like it makes a triangular shape. That's what an expansion bar does. So I'm just going to outline the banks so that you can better see it. Okay. And this expansion bar seamlessly fits the drumlins, right? So the drumlins being the parallel path feature seamlessly fits with this expansion bar. So that all makes sense. Plus it makes sense that we're talking about a saline deposit because we've got, saline scours, salt scablands all over this region, and other locations with drumlins highly correlated with salt around here. So it only makes sense that we're talking about the same water that's in the Caspian and the Black Sea. Now, where did this expansion bar come from? Or let's start off with what is an expansion bar. An expansion bar forms when water is concentrated and then is allowed room to expand. So within fluid dynamics, fluids like to expand when they're pressurized. So for example, when a river goes around a corner, after the corner, many times you can find expansion bars because it's compressed from centripetal force around the corner. So let's track backwards where this expansion bar came from. Came around this way, and then is somewhat in line with this, and we can't really see much. So let's go to a topographical map. Okay, so this is the, oh man. I hate it when that happens. Okay. So here's the expansion bar, or excuse me, the alluvial fan, the drumlins. But unfortunately, all this is underwater. But we can still see that channel I was talking about of the expansion bar. So the expansion bar happens right here. Drumlins are right here. And this is the channel of the expansion bar. We can see that it followed this cliff edge here. This feature right here, why do you have a perfect circle right before this feature? And then perpendicular features? Well, that's quite the thing to interpret. But I'll give you this explanation. This is a plunge pool made from the undulating force of a water current. Then you've got the river scour. And then what forms perpendicular to a water current? Well, that's ripples. So if you interpret this as being a plunge pool and this being a river scour, then you would interpret these as the ripples on the bank of a river, right? So let's go check that out. This is right in this area. So here we've got our plunge pool. In line with our plunge pool is our river scour. And then here we have ripples. And the problem is, unfortunately, these ripples are just simply way too big. It's just mind-boggling. So if you take a wavelength of this in this particular area, it's almost 4 miles, right? So I can't be right. Must be wrong. But nonetheless, according to fluid dynamics, that is one decent explanation. But I will say another feature that could distort this is if these were parallel path features. So this being scablands, and this being, looks like the bottom of a river channel that's been scoured up nicely, that would flow into these being parallel path features, which could have been responsible for these what look like ripples, but would in fact be more like a drumlin. Right, so this location, I can't say for sure. This is one of the few locations on Earth where I really can't say if it's a ripple or a parallel path feature. Another location that's like that might be the second biggest or the largest ripple formation in the world, potentially, which is in Australia, right next to the Australian salt skull, which is an insane feature to look at. You may know what I'm talking about if you've spent a lot of time on Google Earth. But yeah, so that's that area. That's the expansion bar. What was I talking about? Okay, so what I was talking about is where'd this go? Well, there's a cliff edge we can follow, which is actually what this river runs along against. So this expansion bar runs along this. Let's check it out on topographical. Or let's actually get an idea of how wide this channel is, which we can actually see well with the topographical map. It's about 46 miles wide. So we're talking about a major river channel. And that's this channel here, 46 miles wide. On this cliff edge, we see a lot of parallel ravines, right? That's also a feature of sheet water flow. Let's zoom out a tad. Let's follow this river, which follows the cliff edge. And essentially, from up there is the origin of the water that ran along here to make the expansion bar, which is basically in line with the Caspian Sea, right? So when we look at the Caspian Sea and we see that it's kind of vertically shaped, right? Now, of course, there's a lot of tectonic forces that have to do with the shaping of these landscapes. That's how all major landforms are. But we do get an indication from all the features I just mentioned that we kind of get a current coming down into the Caspian Sea to make it kind of stand vertically. Okay, so that's the point of this video. I explained the Caspian Sea. And then if you go up north, you know, massive river channels all up here. All these are river channels. That's River Scour. Let's see this guy here. And none of these have large moraines. I don't know why there's no moraines here. It's almost as if ice did absolutely nothing. All right, let's zoom out so you can see on the topographical what I'm talking about. All this, just looking at this, you can see how everything's made by a river. All of these, this is a 40-mile wide river channel here. They're all right next to each other. Let's wait for it to load. So yeah, these were some of the channels I was showing you. Channels. You even get a little streamlined feature around there. It's taking a while to load. This is why I don't like it, but there's a lot of good data on here. And then as soon as it loads, I'm over it. But this is a good spot here, this river channel. It's in Russia. Come on, you can do it. Yeah, so that's a pretty cool spot.